So the problem I chose to present is problem number 28 on page 493, which reads, what is the variance of the number of times a 6 appears when a fair die is rolled 10 times? This is related to number 11 on page 492, because variance requires the calculation of the expected value. So in problem number 11, I got 0.5031 from the following method. Where I multiplied the value times the probability that that value occurs. So 1 times 1/6 is the value times the probability that the die will come up as 6 on the first roll. And then continuing on, 2 times 5/6 squared, because you get 5/6 times 1/6, 5/6 being the probability that you don't roll a 6 on the first try but are successful on the second try. Continuing on with the 3 and the corresponding exponents, the 4, the 5, so for simplicity's sake I'm trying to simplify this using exponents. I made an error there. That should read 5 to the 7th power. And this should read 5 to the 8th. Now here's where I screwed up the first time. I found a similar example online. The probability is not a continuation of this pattern where you have 5 to the n minus 1 power over 6 to the n power. The probability that a die in this problem will come up as a 6 on the 10th roll is 5 to the 9th over 6 to the 9th. Because the probability that you're going to get 6 on the 10th roll in this problem, it has to be that you're going to get the 6 on the 10th roll. Absolutely, there's no choice for getting the 6. And so that's how I got the 0.5031. Now the expected value in the variance is used, but we also need the expected value of x squared, which means you would square each of the values before multiplying by the probabilities and then doing your sum, which I did using the list functions on my TI-84, which was still fairly tedious. And so I got 35.95 or 96, excuse me. And so we would calculate the variance by taking the difference between the expected value of x squared and the expected value of x, and we get 35.43 essentially. But that number seems relatively high to me, so I'm not quite sure if that's correct. The other question I would have is, although this method seemed pretty solid from what I found online, I was wondering if there were any shortcuts or any other methods that somebody else had found. So that's the problem I wanted to present.